Today.
There you go. It's a Friday. We're starting our final unit. It's the first 4 chapters of the textbook. It's last block. You're a little fidgety, but that's okay. Focus in. Now, the good news, if you ask me, how tough is this? This is lots of vocabulary, lots of interesting factual knowledge. It's not like you're trying to balance equations. Leah, to your right, it's not like you're trying to balance equations and stuff like that. Okay? So, this is sort of biology with other stuff. Section 1.1, we're looking at something called biomes. What are biomes? Well, biomes are the largest division of the biosphere, which really doesn't tell you much unless you know what the heck the biosphere is. The largest division of the biosphere. What's the biosphere? The biosphere is the global sum of all ecosystems. You know what it really is? It's the thin layer of atmosphere that surrounds the Earth and all of the living things underneath or inside that layer of atmosphere. It's the life kingdom. And what we're going to start to do is we're going to start to go from looking at the Earth as a whole to try and classify or categorize smaller sections of it based on what they have in common. And the first division that we break Earth into is 8, I think it's 8 biomes. Okay? It can also be called the zone, biosphere is also called the zone of life. Outer space is not part of the biosphere. It's a closed, self-regulating system. So for us to break things into biomes, how do we break things into biomes? Well, we look for environments with some similar things, with similar biotic components, living things. Yeah, it's where the word biology comes from. So plants, animals, bacteria, and fungi. And then there are the opposite of biotic, non-biotic, except we don't call it non-biotic, non-living, but we don't call it non-living. There's a prefix that means not. We call it abiotic. Biotic, living, abiotic, not living. What do we mean by not living things? The 2 big ones are temperature and precipitation, but elevation, soil type, stuff like that. So the biosphere is broken down into biomes, and biomes all contain smaller ecosystems, and ecosystems all contain smaller habitats. That's sort of the going from bigger to smaller to smaller. You can sort of think of it like those old Russian dolls where one doll fits into another one, fits into another one. So the biggest doll would be the biosphere. The next biggest doll that fits into the biggest doll would be biome. And we go from there. What are some abiotic components? Here's a picture that I found. So here's the abiotic components of a grassland ecosystem. And it features it's the non-living features of the ecosystem that the living organisms depend on. So in the grasslands, you have things like mice, worms, insects, birds. What do they depend on? The abiotic features would be rain. Precipitation is the fancy schmancy word for rain because that also includes snow and fog and sleet. How much sunlight, and not just how much sunlight, but what angle the sun hits us at. That's why I hope you guys know the reason it's hotter in the summer is not because we're closer to the closer to the sun. In fact, in the summertime, we're the furthest from the sun. We're closer to the sun in spring and in fall. Why is it hotter in the summer? Because we're facing the sun more directly in the northern hemisphere. The sunlight is hitting us from overhead more as opposed to at an angle. What are some abiotic factors that affect biomes? The 2 big ones. Temperature and precipitation. If you're on different parts of the planet, but you're in 2 different areas and they have similar temperatures, year-round, and similar amounts of precipitation from month to month, year-round, the odds are pretty good they'll have similar biomes. They'll have similar vegetation, similar plant life, similar... those are the two ones that dominate the most. There are other abiotic, non-living features, but those are the two big ones. So these are the most important abiotic factors that affect biomes. Why? Well, first of all, the amount of rain you get dictates what plants can grow. And if you haven't learned already, plants dictate everything. All of our life comes from, well, all of our life needs energy to live. And where does every living creature that's not a plant get its energy from? Plants. Okay, I lied. There are a few what are called, there's a name from them. They can live in bizarre life situations, like in the bottoms of the lava vents in the ocean. There are a few bizarre organisms that don't actually get their energy from plant life. But most of us, any complicated organism, we get our energy by eating plants or eating things that eat plants. Where do plants get their energy from? The sunlight, in the whole photosynthesis thing that I think you guys have looked at, or you'll look at a lot in Biology 11. So, hey, plants determine what animals, what life lives there. Oh, and temperature determines the length of the growing season. And the length of the growing season determines the type of plants that grow there. You may notice a common little theme in those two. Hot desert, not much rain, not many plants. Cold desert, that's the Arctic. Not much precipitation, not many plants. Turn the page. You need to be able to read, I said, this graph below. So on the left-hand side of this graph, along the height part of it, we're measuring average annual precipitation, the average amount of rain. By precipitation, Justine, I'm talking rain, snow, sleet, fog, anything. Oh, and along the x-axis, along the horizontal, we're measuring average annual temperature. And they range from about minus 20 degrees Celsius up to over 30 degrees Celsius. And you can see those are the biomes there, that list. How many are there? Count.
8.
We generally divide them into 8 biomes. Okay? So you can see already that the tropical rainforest only exists in a certain temperature and a certain amount of rainfall. You can see that a tundra, which is up north, exists only within a certain range of temperatures and a certain rainfall. You may have the same temperatures, but if you have more rainfall, you're not going to get tundra, you're going to get boreal forest. So the two big ones that affect what type of biome you have, temperature and precipitation. So I have some questions for us to answer. It says this region has an average temperature between 5 degrees and 30 degrees Celsius, and average rainfall less than 10 centimeters. So you're a scientist somewhere and you've put a weather station in and you've left it there for a year, and after 1 year it's told you that the average temperature ranged between 5 and 30 and the average rainfall was about 10 centimeters. What's likely the biome that you're in? Let's see. Average temperature in this area, average rainfall in this area. Where's the overlap? Right there. Someone said it already? Probably desert. Now, there are all sorts of different types of deserts. You can break biomes up into subtypes. We're not going to be getting there yet. Desert. You see how we figured that out? On your test and on the provincial, they're going to give you some kind of this graph to translate and guess. Hey, this region has an average temperature of 10 degrees Celsius and receives 230 centimeters of rainfall. It's most like what type of region? It's most likely what type of region? Let's see. 10 degrees Celsius, 230 centimeters of rainfall? Probably temperate. Let's see. 30, what did I say? 10 degrees up this way. 230. About there, Jessica, give or take, yes? maybe looks like it's almost just about out that range, but if we had to make a guess, sure. Temperate. Rainforest. Part of your homework is going to be answering the questions on page 13, numbers 1 to 4. In fact, that's going to be your homework, but you should get time later on in class to do it. Okay? So make a little note. Oh, how about I circle it, Mr. Dueck? And next page. I wrote, turn in your textbook to page 10 to see the distribution of the major biomes of the world. I did photocopy this for you, but your map in your notes is all grays and grays and grays, yes? So eventually I will find a way to either give you a color one, or I'm trying to find one that's completely black and white so that I can just give you pencil crayons and you can color your own. We'll do one of those two things. But these are the biomes. There's 8 of them. Do you notice any patterns? Look at page 10 in front of you if you have your textbook, or look at this behind you, up in front of you on the screen. You notice anything? Jake? So what are the upper regions? No. What biome is that? Begins with the letter T and rhymes with undra. Okay, tundra does not occur on the equator. I can tell you that right now. Right? And in fact, it doesn't look like tundra occurs anywhere near the equator. So the first thing, even if I know nothing about this, if I understand that temperature and precipitation affect this, I can reasonably conclude you only get tundra where it's cold. Now, why is there no tundra down in Antarctica? Because there isn't. I think Antarctica rarely gets above 0. I'll bet you tundra has life forms that need at least some type of spring and summer to survive before they either hibernate or freeze in the earth, but then can melt again when the spring. I don't know, but I can reason all this by looking at that pattern. What else do you see? You had one. Jacob? You had raised your hand. Oh, I thought you were going to. Okay. What? Temperature deciduous forest. Well, you know what? Temperate deciduous forest. So deciduous, there's 2 types of trees. There are what are called coniferous or evergreens and deciduous. So these are leaf-bearing trees that lose their leaves in the winter. They can only really survive a winter that's fairly warm, which is why as soon as you go into the mountains or you go further north, you'll notice there are some leaf-bearing trees, but when you go into the woods, are there more evergreens or are there more leaf-bearing trees as soon as you leave the west coast? Way more evergreens. But here you have the southern U.S., yep, and Central Europe, which is warmer. And, what area of the world is that in purple there onto the right? Okay, China. I've seen movies that were filmed in China, and it seems very lush and green and tree-y. And again, they have other small climates as well. What else do you see? Where are deserts located? Mostly. Okay. Strangely, northern Africa, though, not along the equator. Because a lot of people think, oh, deserts occur because it's really, really hot. It's actually hottest along the equator, and you'll notice along the equator, actually, I'm seeing lots of rain forests. Why? But why? If it's hotter, shouldn't it be drier? Okay, we'll talk about that. But you can certainly see patterns, and we're just scratching the surface. What type of biome do we belong to? So you got to zoom in and find us. I think that's Vancouver Island right there. I can see it on the map. What are we, Jacob? We, BC, and Oregon and Washington, we have our own little microclimate, our own little microbiome. We are temperate rainforest. You may even have heard of, they call it the Great Bear Rainforest as you go up a bit further north. Temperate rainforest. By the way, do you see lots of temperate rainforests on the planet? We are one of the smallest biomes. Where else do we occur? Okay, bottom of South America, which you'll notice is roughly the same distance from the equator south that we are from the equator north, which may suggest our latitude plays a role. Miller, what were you going to say? Yeah, and New Zealand, which I also notice is roughly the same distance from the equator south as we are north. I'm betting part of our biome depends on how far you are from the equator. Maybe not, but certainly I'd be willing to put money down. Oh, what else do those three regions have in common? Yeah, they're coastal. Either surrounded by the water or they have a major coast exposed. The ocean plays a major role in our climate. Why? We'll come back to that. Next page. So what other abiotic or abiotic features affect biomes? What other non-living features affect the type of biome? Hayden, you remember what were the two big ones, folks? Hannah? Two big ones, temperature and precipitation. Another one, latitude. What is latitude? Well, my mom says she gives me latitude when I misbehave. No, that's not what we're talking about here. Geographically, what's latitude? Okay. What we have done is we have divided the Earth vertically, if you're assuming north is up and south is down, which, by the way, not everyone does assume. We do that here in North America, but there is a movement to change that. I'll tell you why later. We put 0 degrees at the equator. And we said the North Pole is 90 degrees latitude. In fact, you may have heard the term, the U.S.-Canadian border is called the something parallel. 49th parallel. Why is it called that? It's exactly 49 degrees latitude from the equator. So a little more than halfway, because half of 90 is 45. Okay? So latitude is the distance measured in degrees north or south from the equator. You break the equator up north into 90 equal segments, or you break the equator south into 90 equal segments. Why do we use the equator as our reference point? Well, at the equator, the sun's rays shine directly overhead. And it's this, Brendan, that means it's going to be hot there. It's the angle of sunlight hitting it. In fact, the equator receives exactly 12 hours of daylight and 12 hours of darkness. Have any of you been on the equator? I have. So I have stood with my left side of my body in the northern hemisphere and the right side of my body. Everyone, you have to pose for that picture. Various countries that are on the equator, they'll have some kind of a monument somewhere. You go there. So I was in Ecuador. What does Ecuador mean in Spanish? Equator. And when I was in that country doing some student teaching, we all drove to the Equator Monument, and you all get your photo of yourself half north, half south. Okay. Not only do we have the equator, there's another major division. They're called the tropics. We have the Tropic of Cancer, that's above the equator. Look at that map. How many degrees north is the Tropic of Cancer? 23.5 degrees north. Why 23.5? We'll come to that. And what do we call the tropic that's below the or south of the equator? Capricorn. It's 23.5 degrees south. The zone between those two lines, which on my map behind you, in front of you is light blue, I'm guessing on your map is still just a blur of gray, is called the tropical zone. The tropical zone. And it's called this because it receives the sun's rays at a more direct angle overhead than in the northern or southern latitudes. And this makes it, well, hot. Warmer. When I was in Ecuador, when I was standing on the equator, it's hot weather year-round. They don't really have separate seasons, a separate summer, a separate winter. It's warm, warmer, warm, warmer. There's your 4 seasons. Latitude also affects precipitation. And this is now going to answer Brendan's question where he said, well, it's kind of like a wet heat. It's hot, but it rains lots. Now, why? Well, where does it get the hottest on the Earth? What did we just say, Brendan? In the equator, the tropics. So what happens then is that air gets heated up. What does hot air do? So it's going to get heated at the equator, and it's going to rise. But when you get higher, what happens to the temperature as you get higher? Okay, it cools off. Now, when you cool off something that's moist, what happens to the water? And you see it all the time. If you leave a pop can that's cold on the counter in a hot day, what do you see on the outside of the can? Okay, it condenses and falls back to the ground as rain. In fact, the tropics receive the most amount of rainfall on the planet. I have been in a tropical rain. It is more than standing under a shower. Far more. It's almost to the point where you have to be careful. If you open your eyes wearing contact lenses, you're going to get your contact lenses flushed out. Okay? We get some good rain here once in a while, and every once in a while, for about 2 minutes, we'll get it really dumping, and that's getting close to what you see in the tropics fairly often. So you guys, we complain about the rain, and we do get a fair bit of rain, but not really. Okay. Oh, which areas receive the least rain? Nope. Now, this is one that kids find counterintuitive, because when you imagine the Arctic or Antarctica, what else do you imagine is there? Snow. And you think, oh, well, it must be lots of snow. A lot of that snow has been there for several years, because once it falls, it never goes above 0. It doesn't evaporate, and so it builds up and it builds up and it builds up. But actually, the Arctic and the Antarctic, they're very dry. They don't get that much precipitation. Winds, yes. Cold, yes. Some precipitation, sure. Lots, nuh-uh. Put your pencils down, look up. What other abiotic factors affect biomes? Well, next page, elevation. So I told you that I did my student teaching for 3 weeks in Ecuador on the equator, but for 2 of those weeks, I was teaching in a city called Quito, which is the capital city of Ecuador. Beautiful city, and it's a spring day year-round there. Wait a minute, Mr. Dueck, I thought you said that on the equator you had 4 seasons, warm, warmer, warm, and warmer. Quito is about 1.5 miles high. Because it's about 1.5 miles high, it's on a mountainside. It's basically a pleasant spring day year-round, 24/7. It's beautiful weather. In the morning, you put on a jacket. By the afternoon, you take it off. Hardly ever rains. In fact, the school that I was teaching at, their cafeteria was completely outdoors. And when I asked, well, what happens when it rained? They looked at me, why would you build a roof for 3 days? That's really all they got. Plenty of fog, and in the evening you had lots of just precipitation. Things weren't dry. It was beautiful climate. So, elevation. What's elevation? It's the height of a landmass. But we have to measure height with a reference point. We measure all of our heights from sea level. So if something has 0 elevation, well, English Bay in Vancouver has 0 elevation, 0 meters, sea level. Temperature becomes blank as the atmosphere. Temperature, well, as you get higher, what happens to the temperature? Okay, temperature gets colder. Why? Because as you get higher, what happens to the atmosphere? What happens to the atmosphere as you get higher? Why do they have so much trouble on Mount Everest? Thinner. And now we go back to our kinetic molecular theory. Remember, we said that heat was atoms bouncing into each other, molecules bouncing into each other. If it's thinner, do you have more molecules or less molecules? If the air is thinner, do you have more molecules or less molecules? Less molecules. So if heat is molecules bouncing into each other and you have fewer molecules, it feels colder. So, the other thing that elevation, that mountains in particular can do, mountains can also affect precipitation. Precipitation. And Hayden, this is the one that we actually deal with the most here in our Pitt Meadows, Maple Ridge area. So what happens? Where does our wind blow from most of the time? That way. Southwest. So it's coming from that way, blowing that way to the northeast. Hey, what's over that way? Mountains. So what happens? The wind hits those mountains, called the windward side of the mountains, and it gets deflected up. Just like if you bounce a ball, or just like when you're skateboarding and you hit a skateboard ramp, you get deflected up. As it gets higher, what happens to the temperature as the wind gets deflected up? Gets colder. So what happens to the amount of moisture that it can hold? It can hold less moisture. That's why that can of pop on the weekend, on the counter on a hot day, gathers a bunch of moisture around it. So it cools and it falls as rain or snow on the windward side. That's us. Okay, reason we get a lot of rain, you've heard rainy, haney, or whatever people say. The reason we get a lot of rain is mountains. And not only that, because there's an ocean over there, the wind that's blowing has plenty of water in it because it can evaporate the water as it blows over the ocean. So it's a moist, warm wind that gets deflected up. Also, on the opposite of windward, here's your new word. Leeward, that's the opposite of windward, side of the mountain. That's the side sheltered from the prevailing wind. As the air drops down, it warms again. And as it warms again, it can hold more water. And that creates a dry land area. In fact, sometimes you'll hear it called a rain shadow. On the other side of the mountain, there'd be a dry area there. If you've ever driven the Coquihalla, you'll notice the effect of elevation change. Keep your eyes open. In fact, at the top, even in the summer, often there's snow, right? So, looking at this chart before you turn the page, grasslands generally occur at a low elevation. Then you have a type of vegetation that we call chaparral or chaparral. That's lots of bushes, but not lots of trees, lots of shrubbery. Then you get the mixed conifer forests. Those are our mountains covered with evergreens at that altitude. Then you get the taiga. So if you look back at the golden ears here, you can see the whole thing. As your eyes go a little higher, you see the trees thin out, but you'll still see green. You get some tundra, and then often you get a snow cap or an ice cap where nothing can grow. In terms of altitude, it doesn't take that much. 4,000 meters and you're there. Mount Baker is a great example. Mount Baker, that snow stays there at the top year-round. In fact, it stays mostly snowy year-round. Now you can turn the page. Ocean currents also play a role. Coastal areas like us, well, if you had to categorize our weather, how would you categorize the weather here for the lower mainland Fraser Valley?
Wet.
And there's one more characteristic. Also begins with a W. We're wetter and warmer. And hey, you notice it as soon as you get past Hope, all of a sudden they get snow all winter. Hayden, how often do we get snow in the winter? Yeah, you know what? Maybe 3 or 4 times. And let's be pretty clear. I have a feeling that in the interior, they wouldn't call what we call snow, snow. They'd laugh at us, right? We shut the school down. They'd be, come on, you guys. Wetter and warmer. Why? What about the ocean? Well, it's a moderating influence. Here's what it can do. It can absorb heat in the summer because it's colder than the air and colder than the land, which means one of the nice things about having the ocean here is our summers are very pleasant. Don't believe me? How many of you have done a summer in Osoyoos or Penticton? Is it hotter there? Yeah. Oh, and in the wintertime, when the air is colder than the ocean warms cold air, which gives us our famous wet West Coast winters. And you may have noticed us, Seattle, Portland, Oregon, this whole stretch of coast, we have almost identical winters. Snow? Not very often. Rain? Yeah. I don't know if we're going to do that just yet. I can't remember. And I'd look at my textbook, but I've loaned both mine out. So, oh, hang on, I have one here. Nearly done. Quick review. Guys in the back row, you're talking enough that I'm going to move you if we don't stop. Okay. Yep. Give me 10 minutes. Okay. Hey, what were the two most important factors, abiotic factors, that were affecting the formation of biomes? What were they? Temperature and precipitation. What are the initials? TP. I'll let you come up with your own acronym or way to remember it, toilet paper, whatever. But temperature and precipitation, right? Temp and precip. Can we abbreviate that for the rest of the unit? Sure. How come? Well, if you combine these two, the temperature and the precipitation, you get what we call...
I heard a phone.
Someone's phone go off? Whose phone went off? So put those together, you get climate. Turn the page.
TP equals C.
Last thing we're going to look at, climate and climatographs. So climate is the average pattern of weather conditions that occurs in a region, observed and recorded over a period of years. And this is where I got to caution you, and this is where I really got to caution society, because I'm going to hear people all the time, hey, was there a big storm in New York last year that wiped out most of the New Jersey coast? And you're going to hear people say, oh, climate change. Climate is an average over 30 or 40 years. One storm does not a climate change make. Katrina does not a climate change make. Now, if you look at 30 years of trends, and then, Jessica, you start to see some differences, then sure. But even, you know, when we have like 5 days of cold weather, really, really cold weather, or 5 days of really, really hot weather, I'll hear someone say, that's because of climate change. You know what? 5 days is not a climate. It's not. It's an average. Climate is an average over a period of time. So just, I caution those of you that are very, very environmentally fervent, which is great. Do good science, because too often I hear people that are very pro climate change, and you know what? The science that they're spouting, that's 1 year is not a climate. Weather fluctuates over decades, over centuries. So how can we summarize the climate? One way is with a picture, with what's called a climatograph. This is a graph of general climate data for a specific region. It's the average over 30 years. So it takes 30 years worth and it averages that into one average year. What does it measure? Hey, look at the graph. See if you can figure out. Average what versus total monthly what? Average temperature versus total monthly precipitation. See if you can figure out which one's with which. Are the bars how much it rained, or are the bars what the temperature is? Is the line how much it rained, or is the dotted line what the temperature is?
Dotted line is temperature.
Okay, dotted line is temperature. Bars is how much rain. This particular location, I didn't tell you where it is. Doesn't say, does it? First of all, can you tell me northern or southern hemisphere? There is a way to figure it out easily. When is summer for this? When is it hottest? June, July? If it was in the southern hemisphere, when would it be hottest? Okay? In fact, if it was in the southern hemisphere, Kenzie, this line would look like, in fact, this line would look more like if you traced out the green curve. This particular place, dry summers or wet summers? Drier summers. This particular place, wet winters or dry winters?
Wet winter.
What's the average temperature in December? What's the average temperature in January? Roughly. Above freezing or below freezing? Above freezing? So this particular place in the winter, would it rain mostly or snow mostly? We can figure out a lot from this graph. In fact, you know what? This is Vancouver. Okay? By the way, Mr. Dueck, I thought our summers got hotter than that. That's an average temperature of 20 degrees. That includes the nighttime, right? Next page. Describe the following climate. Now, on the previous graph, Hayden, they wrote out the months along the bottom. Almost always what they're going to do is just use the first letter. So you're going to see along the bottom JFMAM, JJASOND, Jepmathmathnisondid. I'm assuming you all know the months of the year in order. We'll start with January, so it's always going to be January, February. You're always going to see a JJ in the middle. That's summertime for us. So, looking at this, do you think that this climate is in the southern hemisphere or the northern hemisphere? And convince me. Southern? Why?
Because it's a U shape.
Oh, it's coldest in July. So I'm going to say this climate, wet or dry?
Dry.
I think dry-ish, certainly. This climate does have wetter winters than wetter summers are drier. In fact, not much. Look at this. Not much rain at all in their summer, in our winter. In January and December and February, very dry. How far north or south? Well, now look at the temperatures. Okay. What did you say?
It's in Cape Town.
Oh, you looked down below?
Yeah.
Yeah, this is from Cape Town, South Africa. I was supposed to erase that and I forgot. There was supposed to be blanks there. Whoops. Note to self, fix that next time. Okay. Hayden, you with me? That's good physics, but not climate stuff. You good? Okay. You folks are okay on reading this? Okay. So if you want to look at your textbooks, there's about 5 minutes left. I'm going to give you time in class. We're also going to be doing an activity in class on Monday. But for now, I gave you a reading check that you can work on. The first reading check was page 13, numbers 1 to 4, as I look at my textbook upside down. If you want to, you can get that done really, really, really quickly. And then I also said that you could try page 15, numbers 1 to 5. Answer those. You can answer them on the same piece of paper if you want to. You can get that done now if you want, or I'll give you some time. But next class, we're going to be doing an activity. Which activity, you ask? We're going to be doing activity 1-1C on page 30. We're going to be building your own climatograph. Okay?